It's Friday, June 19th. Welcome to this virtual AI huddle. I'm joined by Shantanu today. How are you doing today?
Hi all, I'm thrilled to welcome you to our first edition of Virtual AI Huddle. Some of you may already know we have been hosting in-person talks on Google campuses around the Bay Area in California, in Seattle and New York City, balancing the challenges from current circumstances and our need to constantly be in touch with our users and developer community, which is yourself. We've decided to convert our in-person AI Huddle event to a virtual event. In doing so, we are opening the doors to AI and ML enthusiasts around the world. Special thanks to Yufeng, who has carved out some time from his busy schedule to give us this talk. Yufeng is a developer advocate at Google, focusing on cloud AI, where he's working to make machine learning more understandable and usable for all. He is the creator of the YouTube series AI Adventures at yt.be/AI Adventures, exploring the art, science, and tools of machine learning. He's an avid long distance runner, and you can find him circling Central Park most days of the week. Yufeng has spoken at events around the globe, including Google I/O, Google Cloud Next, O'Reilly, AI, and Strata, PyCon, PyData, ML Prague, .ai, OSCON, on and on and on. He enjoys hearing about new and interesting applications of machine learning. So please share your use case with him on Twitter at Yufeng G. With that, back to you, Yufeng.
Thanks, Shantanu. It's really exciting to have everyone here, and to kind of talk with folks again. It's been a little while, and I guess I was one of the first presenters early on in the AI Huddle series when it was first, starting in person, of course, back many months ago at this point in Sunnyvale, California. And yeah, it's really nice to be able to be back and to virtually be with everyone here. Really excited to see some of the folks saying hi from all around the country, around the world. Hopefully, we've had a fair amount of set of viewers. You can see the folks saying hi to each other on live stream. Let us know where you're tuning in from. What more do you want to hear about today? I know the focus is going to be on production systems for machine learning, and specifically around using a new kind of tool in a cloud AI platform called AI pipelines. And so we'll take a look at how to set those up, how to use them. And see, we have a comment from Erwin who says hello from Montreal. So bonjour to you, I guess, over in Canada. And yeah, it's getting warm here in the summer, in the New York summer, and really excited to get underway here today. We're going to be focusing mostly on using the Kubeflow Pipelines SDK today, but AI Platform Pipelines supports a couple of different things, and we'll talk about that. So let me know what you want to hear kind of more about with this. And I see people are chiming in. We have Asim from Seattle, Marcelo from Brazil. We have, oh man, this is going to be tough. Avijit from DC, and Biswaranjan maybe from India. So people staying up late to catch the live stream. So really great to have you all. Chris says San Diego represent. And in the on this channel we try to Adventures in the Cloud. We try to do kind of pretty deep dive technical content on really how we use stuff. And so if you have specific you might think they're really narrow use cases, but I assure you there are other people who are running into these problems. We have another Canadian here, Daniel, saying hello from Toronto. So maybe Daniel and Erwin can meet up in Canada sometime. Maybe later when we're finally back to in-person events. So with that, I guess we'll get started. And Tibor says hi from London, as always. Tibor is a channel regular. We've seen Tibor come on quite a number of times, asks great questions. So wonderful to have you join us again. So with that, let's switch over to my desktop. I've got a couple of things set up here. So we'll be mostly working from this particular GitHub repo. I'll drop the link in the chat now. And it's kind of a pre-built set of labs, or you can think of it as a series of workshops around using pipelines. And I don't have really much in the way of slides set up today, but we'll mostly be doing doing the doing, so to speak, right? We'll be really writing code and figuring out what to do here. So this GitHub repo focuses on explaining what pipelines are and how to really utilize them. And one of the things that sometimes gets talked about is why why pipelines are really important. And I see Daniel has a question from here. He wants to know the recording from the last meetup. Yes, we had a bit of a streaming problem. For what it's worth, that has been fixed, and with any luck, we'll have solid streaming connections from now on. We're working on getting the previous recording edited and uploaded. So Daniel, be sure to keep an eye out for that. I want to say YouTube will push a notification to you especially if you have like the YouTube app installed on your phone or something. We'll get that sorted out. We had a little, I guess, what was it? Last Wednesday, 2 Wednesdays ago, the East Coast had a widespread network failure like across the country, and so we lost the internet for a hot second, or it was like one particular provider or something, and my ISP decided to be one of them, so that's fun. Anyways, we'll basically be walking through some of this, and we won't be able to get through all 3 of these in full depth, but I do want to try to touch on them all. And we'll start by talking about AI platform pipelines in the first place. So if you're using GCP, if you're on Google Cloud, where does AI platform pipelines live? That's the first question you got to be able to figure out, right? And so if you go over to our hamburger icon, under AI platform, there's a pipelines button now. You might not have AI platform at the top like I do. What I've done is I've pinned a few things. You can see that you can pin specific items in the console. And so AI platform pipelines, you can get to it if you scroll just all the way to the bottom until it stops scrolling, no more scrolling, and then go up a little bit more, and we have this artificial intelligence section here. And in there's AI platform. You can see this blue pin. I've got AI platform pinned, and so that's why it's at the top for me. So if you're going to be using this frequently, I'd recommend that you do the same. So now I click on that, we go to pipelines, and you see I already have a pipelines open, and I'll show you exactly how we got to that state. So we can click new instance here, and that pops open a new tab. You can see we've got a new tab. I still got this one open back here. And the way that they've implemented this first release of pipelines is that it's using what's called the cloud marketplace. Okay, you can see it in the URL there. It's console.cloud.google.com/marketplace. And there's some description down here about deploying it. And so it's using Kubeflow pipelines as the underlying kind of pipeline runner. And you can click configure to begin creating your own pipelines environment. A pipeline under the hood, Kubeflow Pipelines runs on a Kubernetes cluster. So what it's going to do is you're going to have to pick a cluster zone. You want to allow access to the cloud APIs so that this kind of system, this marketplace system, is able to roll out this Kubernetes cluster for you, install the Kubeflow pipeline software, and do all that good stuff that we want, so that we don't have to manually do that, because manual work is not as much fun. And you can see down below we have a few different extra options here where you can choose where you want to store your data if you don't want to store it on the Kubernetes cluster directly, which is very understandable. Especially in a real production environment, you'd probably want a more persistent data storage method than just putting it on the underlying VMs of a cluster that is kind of more ephemeral, right? You wouldn't want to store data into a container. And so in those instances, you might put it on, say, a Cloud SQL instance or some other kind of managed persistent storage. And we can also notice that you can select an existing cluster. Now, you don't have to take my word for it in terms of these steps. You don't have to memorize all of this. What you'll want to do is at this link that I sent, right, in kfp.cape. So CAPE is Cloud AI Platform. That's why it's CAIP, or CAPE for short. And then this demonstration uses scikit-learn for some of the examples. you'll see that in this README at the top level, before we dive into any of these labs, this README contains a few setup steps that talk about preparing this environment for us. And so we'll come back to this diagram shortly and talk a little bit about the different pieces and where they come into play. But the most important note here is that starting here, enabling cloud services, you'll want to do a set of operations to set your environment up appropriately, ranging from setting your project ID and enabling all of these cloud services. And so this is, again, part of allowing you to programmatically edit your GCP environment. And being able to do that with code rather than clicking around in the UI, or rather here in the UI, is really nice because it means that it is reproducible. So you can hand a script off to someone else and they will be able to do it successfully. It means that it is, you can store it in a, I just blanked on the word, on a source management, a repository, right? In a source management system. So you can track the changes over time and ensure that things can be rolled back as needed if something breaks in your setup script. And so you can see here that this particular project uses the service called Cloud Build to build a few containers that go into your pipelines, because essentially Kubeflow Pipelines is just a bunch of containers, right? It's all on top of the Kubernetes. But what's nice is that these containers give us nice UIs like this one, where you can, I didn't build this web page, it just was part of it, just came with it. So that's a little hint of what's to come here. And so you'll notice there's this note here of making sure we enable access, and that's referring to this checkbox. It's really easy to overlook because it's relatively subtle, and even in the instructions isn't necessarily like the most prominent step. So definitely when you go through these steps, take your time and do each step. I definitely accidentally skipped a few on my first pass through this, and you get burned by it later on when it comes time to actually use some of these permissions. I see Stephen saying hi to you, Stephen, as well. Thanks for joining. And we've got an instance. So then it wants us to create an instance of AI Platform notebooks. So that's talking about the notebooks product right here. It's basically Jupyter notebooks that are kind of self-hosted. I've already got one started up, but basically you can just click new instance. And what's worth pointing out here is the way they've gone about structuring this is they're having us use, I believe, a custom image that, well, at least it's a custom image that's based on a standard image, because in the other lab, or maybe this is the one, yeah, this one uses kind of a fairly common denominator container, and then installs a bunch of libraries on top of it. And I want to say it's this one that, like, it's quite a bit of building, and so it takes a little time to build this image. And so you can run all this either in your local IDE or within Cloud Shell. And as a reminder, or I guess if folks haven't heard of it before, yeah, Cloud Shell is up here in this upper right corner. You can click this little, it looks like a little terminal icon, I guess, right? And that will activate Cloud Shell. And so it'll provision a free virtual machine, basically. You can think of this as equivalent to your local terminal, right? So it's not SSHing into any compute engine VMs that you have. It's a separate VM that kind of sits outside of the world of GCE VMs and allows you to administrate your account from this terminal, the same way you would administrate your account from a local terminal. And so once we've kind of created all these, and we can just follow these steps, and you can see these cat steps. My recommendation is to just create a Docker file called Dockerfile, and then just copy this text into it. Yes, if you just copy this command into a command line, it'll work. But personally, I just find that it's a little bit funny. Like, it's, if you want to do the fastest way possible, yeah, just copy paste blindly. But if you create these files, I feel like you get a little more sense of control, and like, I'm doing a thing. I know what's happening here. It makes sense. And then, yeah, once you've built this image, what will happen is it will show up here in your notebook instances list. In my case, it's this one, KFP notebook. And this button, this Open Jupyter Lab button, they've handily created this reverse proxy, and that pops open this notebook right here. And so once we're in here, we can do the usual things that we would do inside of any Jupyter Notebook or Compute Engine environment. And in this case, we're going to git clone our repo. And once that's in place, we can kind of start clicking into it. So you can see I've drilled down through the folders to get it here, and I've opened the first lab. And so that's kind of the general setup. The one final thing, this step I completely forgot the first time I did this: set up the data. I don't know how I missed this, but you know, once you're into, because I think I got to here and I like cloned the files, and I was like, all right, I'm done. I'm out of here. I'm out of these instructions. I can get into the real thing. No more setup for me. But they have a data set you're gonna want to have set up. So as it says, before proceeding with the labs, I must have missed that line there. And so what this will do is it sets up a schema. Why is this so long? Oh yeah, this is one long variable. Schema equals. It's like, why is this schema in the middle of a bash script? But it creates a table with the data from this little cover type data set that they have like a small version of, so that it can be more simple, straightforward to work with. And so then we have our 3 lab exercises. So the first one, what we're going to do is run custom training in a custom container, which is sort of separate from pipelines itself, but very much related in the sense that in order to successfully run pipelines, we need to understand and be acquainted with this concept of using pipelines as using containers as a way to do work, right? Not everyone in the data science community is necessarily well acquainted with that workflow, so to speak, and it's something that I myself have only in the last few months, maybe, I don't know, maybe a year, but more like last half year, been really getting more into and seeing the value of. And so when you can think of units of work happening in a container, then you can begin to imagine, well, wouldn't it be nice, could it be nice to chain multiple containers together in a series or in some kind of graph structure? It doesn't have to be linear 1, 2, 3, 4, but maybe there's a branching operation or something along the way, or you decide to skip one if you don't need it, things like that. And so that is what pipelines is all about, is making a pipeline of containers that do work. What happens in those containers is entirely up to you. There are some recommended best practices and things like that, but Kubeflow Pipelines is very much meant for the machine learning use case. However, at the end of the day, they are just containers. So you can install whatever libraries you please, and it will happily execute them for you. And moreover, I don't want to get ahead of myself. Let me talk a little bit more about what happens after you build this out. We'll minimize that for now. So once you deploy this, so you see how there's a 2-section thing. So I want to go back to this just for a moment, because it's worth calling out the fact that even though this looks like a single page setup, it's actually a 2-parter. This first part, you can see there's a button, create cluster here. That button is going to create our Kubernetes cluster. And arguably this should say create Kubernetes cluster, just to make it 100% clear what's happening. You can see it in the description here in the gray text, but come on, let's be honest. If the text is gray, most people don't read it. So they think it's optional, right? It's just a little side note. And this creates a Kubernetes cluster. And only until that Kubernetes cluster is created, that's basically provisioning that virtual hardware, then we can put the software on top of it. And so that's what the second half of this page does. It takes the software and loads it into that cluster. And so if you don't want to create a new cluster, let's say you have an existing cluster, which I do in my case, right? We can choose one. Apparently I don't. That's cool. Where is the cluster that I was using? Was it not Central 1? It was Central 1. It must be because I didn't, cluster does not fit the application. Cool. The cluster is too small. So I could resize it, or I can create a new cluster. So when you create a new cluster, I'll show you the cluster that I've got going. How about that? We'll see what happens when we create cluster, just to save us some time of waiting for a cluster to be created. So this is the cluster that Kubeflow Pipelines created, and it's got 3 nodes, right? So not the biggest cluster in the world. And if we go to the underlying nodes here, we can see that it has 3 nodes, 2 CPUs each, half a gig of RAM. So it's nothing crazy. Sorry, 4 gigs of RAM. So I think it's an NY standard 4, and it's nothing crazy in terms of, it's not a big machine or nothing like that. So it's got a master, it's got 2 worker nodes, and that's all you need, for just getting started. And then as you put on bigger workloads, you can upgrade the cluster. It's worth thinking about the architectural piece of this. So let me go back to here, as I promised. The notion of having your Kubernetes cluster do all the work for you is one that is commonly talked about in applying CI/CD approaches to I'm going to go to this view, applying CI/CD approaches to machine learning, right? CI/CD typically will run everything in that environment. It will run it inside of its own CI/CD environment. So whether that's Kubernetes or otherwise. And so when folks started building toward machine learning use cases, that's what happened as well. But what I think we're beginning to see is that there's also value in using these pipelines to make API calls out to managed services that can take care of a lot of this stuff, either more efficiently, more easily or simply, and more transparently in some cases. So sometimes it makes sense to literally just run your machine learning training, right? Hours or days or weeks right inside your cluster. You want to hold on to it and manage it yourself? Great, do that. But there are times where you have a more well-oiled machine, so to speak, and you don't necessarily want to maintain every single part of that machine. So examples include, let me go back to this view. You can imagine a situation where you have AI platform pipelines that call out, use from Kubernetes to call out straight to things like AI platform training. Sorry, my mouse has decided to fly around without my control, so that's cool. You can run training jobs, right? Instead of running the training directly in your pipeline, you can just make an API call and give a, let's say here I have a hyperparameter tuning job of ResNet. Instead of writing your own hyperparameter tuning job, you can use an existing service for that. Or for instance, if you, we saw actually here in the setup, right? We made BigQuery take care of storing our data for us. You wouldn't want to store your data within your cluster, of course, but you might take it, do some work on it, and then throw it back out to a different, more persistent storage system. So let me know if you have questions about that or thoughts, in your experience of, do you have a preference around having your own data, your own workloads managed by yourself or for you, right? But for now, let's get into it here. In this first kind of lab that talks about custom container training, what it does is it is very much focused on getting the data trained within a container. So I'm going to kind of skip down in the interest of time, so that we can get to the second and third labs, which are a little bit more interesting. But I'll highlight what is happening here that is notable. Firstly, it's using BigQuery to create a training split for us. And so that's an interesting concept, right? Using a SQL query to chop up our data. And so you can imagine a situation where you use an architecture where you use something like PubSub to stream data straight into BigQuery, and then once in a while run a new training job. And when you do that, you are accumulating more and more data, and each time you're going to want to carefully select, shuffle, and split your data in such a way that your training remains reflective of the data that's coming in. Perhaps you have like a rolling window where after a certain amount of time, the data becomes stale and you don't include it in training anymore. Or you have some kind of weighting where newer data counts more heavily. And so here we create the training split and the validation split, and then just as an example, this notebook uses sklearn, scikit-learn. Of course, you can use other libraries and other kind of more sophisticated systems. Mostly this was to allow training to run more quickly. And so some of the notable kind of concepts and calls they're making here, because this does not look like normal scikit-learn code in some ways. So if you search for column transformer, scikit-learn has a set of pipeline commands. So this is where you have a situation of a little bit of mixing terms, right? Scikit-learn has pipelines. These are not the pipelines we're using. So it's like we're running pipelines inside of pipelines. So specifically, scikit-learn pipelines are being run inside of Kubeflow pipelines, which are run by AI platform pipelines. Oh my goodness, it's a lot of pipelines. And so this is how scikit-learn likes to structure pipelines. So within a single container, we're going to have a pipeline. And the pipeline has some conversions, and we are able to run that scikit-learn pipeline locally. So when it says here, run pipeline locally, it's not talking about running a container-based pipeline. It's running a pipeline, scikit-learn pipeline, in a container. Or I guess right now it's not even in a container, it's just in our VM. And so once that training is done, it also has a little hyperparameter tuning application. And this is one of my gripes when it comes to Jupyter Notebooks. So rant warning, I guess, fair warning, that I'm about to go and talk a little. One of my annoyances around Jupyter Notebooks is that this is becoming, some people are really turning to this as a way to generate Python files from Jupyter Notebooks. It's like people say, oh, don't use Jupyter Notebooks for production systems. And then the response being, great, I'll just use Jupyter Notebooks to generate Python files, but not actually convert the Jupyter Notebooks directly. I will have a cell that has the text body of the code, which I've copy pasted from the cells above. Honestly, I personally don't think that makes a lot of sense. It means that every time you change something in your code up above, you have to remember to change the code down below, which feels silly. But maybe that's just me. I'd love to hear from you all how you let me know in the chat how you go about addressing this particular issue. So this one writes it out to a file, and then it packages that script into a Docker image. Into a Docker image. So again, we see this idea of it writes a file, but at least this one's shorter. Like at least it's manageable. Though honestly, I don't know why I feel like there's nothing programmatic about this text, right? Like this is literally just hard-coded text. Why not just put that straight into the file, into the folder that it wants it to be in? You don't necessarily need to create a script to generate that manually. The build, of course, is important. This is using gcloud build, which is nice, rather than using the local virtual machine to build it, or if you have this notebook running in your local environment, it would be using your local CPU power. You can shoot it off, and I've had great, what I personally feel like is success with using cloud build. It's convenient, it's simple. It's one of those things that seems to just work. My probably favorite workflow aspect of using cloud build is that I don't have to run Docker build and then Docker push, because it kind of does both. It shows up in Google Container Registry directly after it finishes building. I don't need to tell it to put it there when it's done. It just does it, which makes a lot of sense. And then here it's using an AI platform hyperparameter tuning job rather than doing that manually. So this is an example of using a container and then leveraging it further, because AI platform training, which is under the jobs menu here, it allows you to give it a custom container along with a bunch of different inputs to try. So you can see here there's a couple of parameters that it's testing. One is the max number of iterations, and the other one is this alpha value. I believe that's referring to learning rate. And so the code that we had way up above there is kind of testing is able to read, knows about these two values. And so this would be a good example of a file being generated, because this again is hard coded, but it doesn't have to be. It could have pulled in the names of these variables. Let's say we called them something different, right? That would be a nice kind of metaprogramming piece to put in here, rather than having it be customized, or rather than having it be hard-coded. And then we kick off the hyperparameter tuning job. It looks ugly just because it's using a lot of variables here, but and Jupyter has decided to color code these with really bright red $signs. But if you can get past all the dashes and the equal signs and the $signs and the slashes, it's fairly straightforward, right? It's the normal training command, AI platform job submit training. So we're job submit, and we're submitting a training job. Seems a little repetitive. And then we give it a name, and then there's region, a folder to put it in. So that's the Google Cloud Storage, GCS bucket that you want it to live in. There's this master image URI. So that's the container image URI, the gcr.io / URL that we have our image in. So you can see here, this is the image URI, which we stated up here. So gcr.io / these three terms, which is project ID, image name, and image tag. And then we've got, then it just has monitoring the job and waiting for the results. So part of the reason why we didn't, run this manually is because hyperparameter tuning jobs take a while, and we only have so much time together. And then it actually has this interesting notion of retraining the model using those best hyperparameters found. And it uses the combined training and validation splits as a training data set. I have mixed feelings about that in terms of whether that should be done. I could see a different approach where you use the hyperparameters that are found and maybe you train it longer, right? So you use hyperparameter search, you cut it short. You say, I'm just going to train for 10 epochs and see which one of the hyperparameters in this space seem to be working out the best. And then I'm going to take maybe the top 3 and train them all the way and train them for 50 epochs or something like that, whatever is appropriate for your data set. And that I think would be a suitable way to do it. But again, there's a timing aspect of it in terms of perhaps this was set up this way so that the so notebook runs in a timely manner, right? So instead of training it longer, we're just training on a little bit more data and call it a day. Oh, there's extra space here. And so then they deploy it. And so this is another step that we could put into containers. So each of these kind of discrete steps will get put into a different container. And so that's exactly what's going to happen in this second lab. So this brings us to lab number 2. Lab number 2 is going to look very similar in terms of the concrete pieces of the code that's going in, but this time everything will get packaged up into a container. If I recall correctly, we won't explicitly have to do all of the scaffolding to make those containers, and that's part of what this system does for us. So we have, let's see, the pipeline design itself, right? So we have a couple of different images that we're going to put on top of our base image. And this particular pipeline is using kind of a mix of, there's pre-built components, and then we're going to throw some other stuff on top. And there's definitely some work left to be done here in terms of making these a little more clear from like a documentation and ease of use standpoint. The 3 that they're going to use is BigQuery, right? Because earlier you saw we used BigQuery to generate our data set. And so instead of writing your own API code, they've built a little wrapper for us, basically a container that takes in arguments to specify what the query should be, what the project is, what table it's on, or data set it's on, things like that. And then there's the AI platform training component and the AI platform deployment or prediction component, which takes care of training and deployment. So this is actually an exact example of using managed services from your pipeline, right? Using your pipeline as this like orchestrator that is going around and saying, okay, get the data, and then send it off to training, let it train, rather than training it on the local cluster. And that's why we were able to get away with just having a 3-node cluster, master and 2 workers. It's pretty lightweight. And so there's a couple other components you can build on top of this lightweight Python components system. And we'll take a look at the code for those lightweight components in this helper components file. And that's what the two are. One is to retrieve the best run, the other one is to evaluate the model. So again, we have this write file thing that I'm mixed feelings about, but this is how the training pipeline is defined. And so instead of going through this cell to show you the code, I'm actually going to go to the GitHub repo and open up the file that was generated under cover type training pipeline. Right? Is that the right one? Yeah. So we can see here the generated code is very similar to what we saw before. It's got our training, validation, and test paths. This is the hyperparameter settings that we saw in that file before. And it's got a couple of helper functions. What I want to highlight here is that there's this generate sampling query, which has a query that is going to be very similar to what we saw before, but it's been parameterized. So we see in lab 1, if I go up, try to explain this as clearly as I can here. So this is the query, okay? And what it's doing is it's saying modulo absolute farm fingerprint and of this cover. And what is this cover? It's select star from cover type dataset as cover, right? So where, and this is where it kind of gets interesting. This parentheses is on the mod, so it's mod 10, and then it says in 8. And in the lab, here, we have the same sort of thing, right? Select star from that source table, it's the same table as cover, where, and then same modulo absolute from, then it says num lots in lots. And so they're using this concept of lots, or just like partitions, but you can't say partitions because that's a specific term when you talk about databases, so they use lots and use that to basically sample slices of your data. And what we'll see is when it uses the this generate sampling query in these two spots. No, this is definition. This is pointing at itself. Let's see if I can find it here. It calls generate sampling query, and you can see here num lots is 10, and the lots are these 4. So it's like in lots 1, 2, 3, 4. And then over here you can see the splits is in lots 8, and that's the exact query that we actually saw here. It's 10 in 8 for the validation split, whereas the training split was 1 through 4. And then is there not a test split? There's not. It's kind of strange. And oops, too many tabs. Okay, so that's how it's creating our training and validation kind of chunks. And we can see here's the actual, looks like here's the test one. It's 9. So 1, 2, 3, 4 for training, 8 and 9 for validation and test respectively. And then it calls all of these, and so you can see here ML engine train up. This is a little bit of a legacy term. It's referring to AI platform training, which hilariously is still under the ML engine folder. It used to be called GCP, AI platform used to be called ML engine, machine learning engine, about a year ago, and they just rebranded it. So it's a different name now. And I was asked before we go on, I wanted to throw up this question for you folks, if people don't mind answering. Shantanu asked me if we could have a little, call it a survey. I don't necessarily remember exactly what's in here. I might just test it out. So it's bit.ly/ml-pipelines. So you can see the text over here by the mouse. But yeah, there's a survey just briefly about kind of how you heard about the talk. You can say either Meetup, Kaggle, wherever, maybe you put YouTube channel or something. If you've been frequenting the channel, let us know what sort of thing you might do, whatever title, and there's just a brief survey. And notably, Shantanu is a UX researcher, and he's interested in kind of your use cases and things like that. So if you're feel happy, want to share that with us, you can let us know if you'd be interested in being contacted for user research studies to help shape products. If you say yes, there's a next page which I can't get to because let me just check off a few things. Don't worry, Shantanu, I won't submit this form and make a dummy one. But you can put in an email if you want. But if you don't, want to participate in this, it won't ask you for your email, and you can just submit. So we will not sell your email address. Don't worry. So yeah, if folks don't mind completing that, that'd be awesome. And I'll put the link into here so that it's easier to click. Survey. Here you are. So there's that for Shantanu's curiosity. And another kind of side note, sorry, when we got sidetracked from this ML engine thing. So you have these two, thanks Chris, for filling out that survey. We got the two here that say train and deploy, even though now it's called training and prediction. So that's why it's called ML engine deploy. That explains it. And op is just short for operation. There's this notion of doing kind of operations. They're just pipeline components. And so that's this whole thing, right? It does all the things up to and including evaluating the model. But you'll notice that there's the train op and then the deploy op. So it'll even do the deployment. But there's no hyperparameter tuning or any of that. So it kind of strips out some of the stuff. Oh, I guess, no, the hyperparameter tuning did happen. It does the training with the hyperparameter tuning. Then there's this retrieve best run thing. And then it trains it again, remember, because it does the hyperparameter tuning and then it trains it again with the best cases. And so now we get to the fun stuff, as some people would consider, lab 3. This is where we really build a CI/CD workflow for automatic deployment, right? To integrate that workflow with GitHub. Oh, but before we do that, I wanted to call out a detail here, because what this is actually going to do, this pipeline, because I skipped ahead. What we just looked at was just this one file, right? This training pipeline file. And I'm going to scroll down. This is why I didn't want to do it here. It's such a long thing. Once that's been created and we have our Docker file, which is very simple. It just has the base CPU image from the deep learning virtual machine, install scikit-learn pandas and Kubeflow pipelines on top. That's what KFP is short for. Then we can kind of deploy that pipeline. Now, this is where it gets interesting. This pipeline has an endpoint. And the pipeline that we'll be using is this one, right? So once you have a pipeline deployed, and if you've been following along, maybe this is done deploying for you by now, and you can go check and you can click this. What that will do, it'll pop you into here. I'll put this tab over here. It'll drop you into this kind of getting started page. And there's a couple of tutorials and really interesting things here, but you can just go on to pipelines for now, and you'll be able to see these 4 tutorials and demos. You won't have these 2 because those are pipelines that I've created. And notably, I want to call your attention to this URL. All right. So some things to note. It's not on my local host, right? This is running at a HTTPS location. And specifically, it's being hosted, and I didn't have to do any kind of real network setup to make this work. Moreover, when I run this, it's going to have a value in here. So you can see, let me pull up the Jupyter notebook that is in GitHub. So if you clone this and you go to this, you'll be able to see this endpoint. That is not your endpoint. It is also not my endpoint. My endpoint is this URL, and yours will be a different value too. So carefully replace this. You'll notice that it doesn't have HTTPS at the front, and at the end of it, there's no slash, right? It just ends with .com. The reason why that's important is that it does some concatenating later with that, and so if you put not quite the right characters in at the front or the end, it might tip things off a little bit. So that's the endpoint. Artifact store URI is a Google Cloud location that is a cloud storage location that is created for you when you made your pipelines. So that bucket name always starts with hosted KFP default. And my recommendation on how to find it, I thought I had put it here, I might not have. My recommendation on how to find it is to use something like, let's see, yeah, that's not gonna work. GS util ls and just ls, because that'll do all of our bucket names, and then we'll grep for gs:// I probably should put this in quotes, hosted KFP default. And because this is Jupyter, we want to do that. I had this in a script at some point, I remember now. And so with any luck, this will pull out that first value. Now here is what really I got tripped up by. See this display? It comes with a slash. It comes with a slash right there. And that slash, we don't want that slash. At least the way this notebook is implemented, this artifact store URI value, if you put a trailing slash on there, what will happen is, whoa, that was weird. Did not expect that. Okay, I just like pasted something weird. Okay. What I wanted to search for was this. Search, paste. Okay. So if you include the slash, let's see how this variable is used, right? Down here, what it does is it puts slash staging on this artifact store URI. So if you already have a slash, it's going to double slash it. Should it have used os.join? Probably. Path.join, right? Os path.join, probably. That would make sense, but it didn't. So, you know, obviously you're welcome to rewrite this and to your own taste, but that's, you know, way down there. And so that was a subtle bug that took me a good while to tease out when I accidentally put the slash in there. So please save yourself and don't include the slash. You'll notice that the way the way they've done it here, there's no slash either, but it's easy to miss, especially because I was a little bit overzealous and I did something like this. What did I do? I was like, bucket ID, I forget if that works. Right, so then my bucket ID was this value and it was like this bracket, and I was like, okay, let me select the first value out of that. Okay, cool. So then I got the bucket ID, and so I just saved that. And so I didn't copy paste it in place, and so that slash got hidden. So like what you'd probably really want to do is something like this, like something like that. But like, look at this. This is a mess. It's okay, I guess, right? So you could get away with something like that where you manipulate it that way and store that into this artifact store URI variable. So random funds, I guess, fun thing you can play with. I don't know how people feel about doing a ton of kind of magic number manipulation on array-like objects, list-like objects, but so then we build the trainer image. This is the same as before. You can see it takes a bit. There's a lot of steps here. Probably should have suppressed this output just a little bit. Oh my goodness. Okay. We got there. We'll get there. And then we build the base image for the custom component. So all those custom components also have images. So we make that. And then we compile this pipeline. So this is kind of an interesting thing. We take this Python code that describes the structure of the pipeline, and we describe that and then you run it through this interpreter, this CLI. There's this DSL-compile, and this is referring to the Kubeflow Pipeline SDK. And you say, it's come from Python. Here's my Python file. This is the Python file that we were reviewing up here, not this notebook, but the one earlier. Right, that long Python file that had the part that obtained the data, it did the training, it did the hyperparameter tuning, it deployed it. So basically everything we needed to do was all kind of tied up in there. And you see here --output cover type training pipeline .yaml. And so it's going to convert this Python file into a YAML file. And so we can take a look at what that looks like, the first couple of lines at least. For anybody who is a whiz at YAML, feel free to enjoy parsing this. For everybody else, I have a feeling you're going to really appreciate the fact that this this converter, this CLI exists, right? That is, where is it? Yeah, TSL compile, that it can compile our Python code into, where did it go? Oh, it's this tab. The double tabbing thing when Jupyter Lab always trips me up. Is there a does anyone know if there's a shortcut to change tabs here rather than changing tabs up there? That would be really cool. I guess there's a tabs icon. Ah, this is the answer. Activate. What is this? This is Control Shift bracket. Okay, so it's basically replacing tab with, well, it's not. Yeah, I'm not. Okay, this works. This works. Random tip, I guess, for folks who, if you were like me and didn't know that these two existed, you can go back and forth. And it looks like you can also toggle tabs with the single quote, but this time it's Command Shift. Okay, neat. Very neat. Anyways, that side tangent aside, we've got these steps, right? And so you can see, you know, at first it looks pretty orderly. You have each step, it's got different images, base images, names, all that good stuff. And then it's surprisingly terse. Is this the wrong YAML file? I think it might be the wrong YAML file. That's why it's so terse. Cover type training pipeline.yaml. Right, that's why. And I don't think it's actually something that's been saved in here, but it's super duper long, and I think since the code is already there, it will, maybe not. What did I do wrong here? Because I didn't really run the code before it, so, you know, probably means it won't work. URL search prefix plus, ooh, that looks like a bug. Yeah, this is inside the compiler. There's a URL search prefix plus path suffix, and apparently one of them is not a string. Oh, it's probably because it didn't provide it, and it didn't do type checking beforehand. Let's see. So this is from the BigQuery op. Yeah. So that looks like it's within split text. File name at 0. There's no file name, I'm guessing. So that's something I'll have to debug later. But this is kind of a taste of what the YAML looks like. It's kind of a mess because the source code is embedded into the YAML file, right? All right. So with that said, let me talk a little bit about deploying this pipeline. So you can see it uses the CLI to display a lot of stuff. Because again, you can use this stuff. You don't have to be in a Jupyter notebook to do this. This is just a way to organize all of these steps. KFP endpoint. So this endpoint again is this URL right here, and we can upload our pipeline to that URL. So let me talk a little bit about what's happening here in this pipeline. Once it's been uploaded, this is our cover type continuous training. A pipeline, you can think of it as a recipe, right? It has a bunch of steps, but you have to cook the recipe to get any outputs, to get any product. And so this pipeline hasn't been run yet. It's just a set of directions. It's got your code, it's got all the things, but it doesn't actually, you know, nothing has been executed. And so if you want to run your pipeline, you can see the YAML. This is the full YAML. There it is. And so, yeah, so for example here, you can see this is a custom one, the retrieve best run. And you can see it's literally just the source code with a bunch of new lines and stuff, just straight up put into the string. And here's the other custom one, evaluate model, that selects the best model. But a lot of the ones are normal, quote unquote, not normal, but pre-built pipeline components. So you can see here, BigQuery query 3, BigQuery query 3, double query. And you can see all of these inputs are all parameterized with these double curlies. So you can technically edit these, but you really don't want to. Here's our query, right? You might recognize this, our select star, but you can see every single new line is captured in here. So it's not the most fun thing to read. And you can see here, there's our image things. There's another similar query. So all the custom pieces are kind of captured in here. And so we can create a run, and it'll auto-populate a bunch of stuff, and we can give it a run name of your choice. It'll auto-generate one as well. And then we can associate runs with experiments. So this is where Kubeflow Pipelines, the kind of customization and built for machine learning aspect of it really comes into play. Because you can group your runs together by experiment. So this concept of running pipelines as experiments lends itself really very nicely towards machine learning use cases. You can build multiple experiments, have lots of runs within the experiment. It's a nice way to organize your work. And you don't have to have everything be in an experiment. One-off runs you can just throw into this default experiment, which is what will be selected if you don't pick anything. So I'm going to choose this experiment. And you can even have reoccurring runs. So for situations where you want something more CI/CD-like, you can have reoccurring runs that handle that for you. So I'm going to click that just to show you what it kind of looks like. We can have periodic triggers as well as kind of cron job triggers, where you can just have the cron expression here for those of you who do cron runs. And you can even have concurrent runs and kind of limit that if you need to. And there's catch-up runs if things are behind schedule. And then there are all of these parameters you can set. So these parameters are parameters required by the pipeline itself. And so I don't remember exactly what all of those were. Oh, right, because here what we're doing is we're going to submit a run programmatically. What ends up happening is you can see here KFP endpoint run submit, and you can see all of these project ID, GCS root, region, and so on, source table. They're all coded into the text rather than having it be manually pasted in here. You can see the same kind of values are being asked for here. And so generally I won't run a pipeline from the UI, especially when they're more complex. It makes a lot more sense to do it from the command line or from the notebook, because a lot of these variables you already have in the notebook, or you can just like very much directly set in advance like this. It's much more straightforward than going to the UI and copy pasting values directly into this each of these fields, right? Like literally you have to go through and paste and paste and paste, and nobody wants to do that. So this is a lot more straightforward. And then monitoring a run, that's where it gets nice, where you can start a run, and I'll show you some of the runs I've done. Let's go over to experiments, and you can see under here apparently I never got cover type training to run properly, so that's cool. But you can see, what did I do? Oh yeah, I had this weird race condition that I eventually fixed. I don't remember if I fixed it in this particular pipeline, but yeah, eventually I got it fixed, but then this never finished working. But there was a weird behavior where if the table didn't already exist, it would try to make the table, and what would happen is these three would run, 1, 2, and 3 would run kind of at the same time, and because they don't depend on each other, so the pipeline just says go ahead and run. And so maybe query 1 says, oh, the table doesn't exist, and then the second query running at the same time also says, oh, the table doesn't exist, and then they're in a race to see who can create the table fastest. And so one of them creates the table, and the other one is like, oh, I can't create this table, and it fails. So there's funny concurrency issues that you can run into when you start doing this stuff. So keep an eye out for that. And so debugging becomes kind of important, being able to see the errors. And so let me show you what we were seeing when we were doing this. So go to the ones that failed. And you can see here it failed, and we can go to the logs. So this is much. Oh, come on! This was from too long ago, so it doesn't. the pod doesn't have the errors anymore. Sad. So, but in the moment, you could like really scroll through, and it was a lot more convenient than trying to command line dive into the logs themselves. In general, what you'll find is a lot of this data is stored pretty deeply in cloud storage in some cases, and it's like many folders deep if you navigate by hand, but the UI is able to pull it out manually. Yeah, so Julian asked the log should be in stack driver. That's absolutely true. So you can see it here, the notes or troubleshooting guide. No, I don't want the troubleshooting guide. I should probably open a new window, come to think of it. Logs. Yeah, this probably should be, yeah, and there's a link there if you saw it there. So thanks for pointing that out, Julian. I'm just gonna have to go back and find it, which, you know, I may or may not be successful in pulling off. Though I haven't used this this cluster in a bit, so should have something come up, but we might find the successful runs that came after these failures first. Like I said, it's been a little bit. So while that's searching back, let me let's take a look at this third lab, because I don't want to forget to do this piece. So this third lab, oh, let's try that keyboard shortcut. Yeah, that's that Control Shift and then bracket. This third lab is all about creating this workflow, and you can even integrate this workflow with GitHub to set up triggers. And in general, what this is going to use is Cloud Build, right? So Cloud Build is a way to automate a lot of this stuff. And in particular, we're going to automate the steps we did manually during this second lab. And it lists it out here. And so we did do a lot of those steps manually, right? Everything from building our image, pushing it, uploading it to the pipeline. It doesn't run the pipeline for you, but it will take care of everything up to that point, which is pretty nice. So let's put in the endpoint. Try to get this right. You can also, if you don't want to copy the whole thing, just do everything between the HTTPS : / up to, but not including the period before pipelines, because everything else is the same. And so what you can do is here to here, paste, and replace that. So we can run that and have it pull out the relevant values. Don't know why it didn't work. Oh, there, it finished. Okay, that was weird. But it still didn't print it out. Oh, right, of course it wouldn't, because this is suppressed with the equal sign. Good. Always good to make sure you're in the right project. And let me just take a peek. Okay, so it doesn't look like the logs linked back for whatever reason. It might be because the machines, well, it still go to stack driver. That's weird. So creating the CLI builder. So this, they have a little Docker file for basically just KFP by itself. We're going to use this because we need a container. It's funny. Cloud Build needs a container to do the building and compiling of your Kubeflow pipelines, because everything now is going to be done in Cloud Build rather than on this local machine, including converting that Python file to YAML. And so we can build that image and push it to the container registry. What is funny here is, right, I said we're not going to need to do, we're supposed to be building a system that automates all that. But in order to build that system to automate the Docker builds, we need to do some builds. Yeah. So that's kind of funny, right? Because at the end of the day, you have to build something yourself. And we're just trying to get to higher and higher levels of abstraction, essentially. All right, so let's see. That looks like it finishes. And then you can manually trigger Cloud Build runs using this Cloud Build. So there's a bunch of substitutions that we'll use for our endpoint, or rather it just substitutes the endpoint. I don't know why it has this whole thing in there, but it needs to, these are all the arguments, right? And most of these are already preset, but it needs that endpoint value here. And in general, it looks like we're still waiting on this cloud build submit to finish running. And I guess when it does, we'll want to build this next one. So this is to have us manually trigger cloud build just to test it, I guess. Oh, no. This is literally triggering our entire build pipeline. You can see here, we have our pipeline folder, we have our cover type training, we have our training pipeline, all the different components that we were caring about earlier. So we can see that if we go to lab 3 and under pipeline, we have it's the same folder as before, right? That pipeline, and then trainer image has our our Python script for doing the training, and the same Docker file for that, where we install our hyperparameter tuning scikit-learn packages, and this is the cloud build YAML. So that's what's being used. I thought I saw it fly by for a hot second here. Yeah, this one, this cloud build YAML. So, and then all the substitutions that are being passed in here, you can see these underscore values are, yeah, that's right, are shown here in this. This is cloud build.yaml under this lab 3. And what we have is a bunch of values that can be substituted. And all of these $, then underscore something will be replaced with their true values shown here. So that's actually a really nice way to structure it. It looks like it is still building. Okay, let's look at the next thing then. Let's see if if the build is fast enough to keep up with the talking. This is for setting up GitHub integration, so that we use the cloud build GitHub app to set up a trigger that'll start a CI/CD workflow when a new tag is applied. Whoops. To apply to the GitHub repo that is managing this pipeline source code. Good. So if we take the getting started, create a fork of this. Oh, right, fork this exact repo, not literally that repo, but the repo that we're in right now. Then they want us to, I'm just going to preview ahead a little bit, create a cloud build trigger, and then we can trigger the build. Okay, so let's wait for the values to show up. I'm curious how this was. Wow, this is very in-depth editing. And I'm curious if folks can let me know in the chat, how much do you all use GitHub triggered CI/CD workflows in general and specifically for machine learning? I'm very curious how much this kind of workflow resonates with folks, as opposed to other types of integrations. Instead of GitHub, maybe you're triggering with other tools and other software systems. So if I go ahead and fork this repo, fork, that's funny, it stuck a fork in the book. And once that's in place, this is my own copy of this. Then we connect the fork that in the previous step to our project using the creating GitHub app trigger, and then we have to edit these values. So there's a number of values here, and you can see these substitution values are now going to be added into the trigger manually. So this is an interesting approach to making this work, right? So we have to install the cloud. So this is like a whole nother workflow. I don't know that we necessarily have the time to step through this manually. Unfortunately, it looks like this build is still going, so maybe we do. Again, let me know if you want, vote with your feet. Let me know if you want to hear more about kind of this cloud build piece of it, or we can dive more into pipelines, talk about artifacts and executions, some of the other pieces of this pipeline workflow. Generally using GitHub and cloud build together is fairly common. So Julian says that he's used cloud build triggers extensively, but lately GitHub Actions have replaced some of them. Okay, so that's a fair point. GitHub Actions is definitely kind of the new kid on the block in terms of really changing the game, right, on this. And so it'll be interesting to see how we can rework some of these workflows and adapt them to new approaches to this setup. And Julian also mentions that GitHub Actions can be used to create the container that will be used in Cloud Build, so that it actually adds a little extra. So now we wouldn't have to do this container building ourselves manually beforehand, which, yeah, I can see the value of that. So before we go forward to that, so let me know which way you want to go. But meanwhile, I wanted to highlight kind of a couple of these diagrams now that we've had a chance to talk through the code conceptually. Hopefully this image makes more sense. And so we kind of started here in a way, and then we have training and prediction over here, and then we had our data over here in BigQuery. It's not the most well sequenced diagram in the world, right? Really the data should have been earlier and things like that, but you have our BigQuery data starting us out, and then taking it and then pushing it into training. And this whole thing is being managed by AI Platform Pipelines. So that's what this is talking about. The diagram here this is the Kubernetes engine icon. And there is a pre-processing data flow step, which kind of we didn't go over too much, but it's basically taking that data and it's running a pre-processing step before it goes into training and turning it into TF records. And so then we have our artifact store where we stored all of our data, especially those slices. And then when we layered on top of that, right, everything above this piece is the CI/CD bit, wherein we had GitHub triggering Cloud Build to do this. Or if GitHub wasn't there, you can basically skip over it and say we manually triggered Cloud Builds, which of course pushed containers into the container registry, which then informed what was in the pipeline. So it looks like the build finally finished, so that's cool. It's just a lot longer now. Wow, this is a very long build. I'm gonna have to review this later. This is something else. Wow, that might have been the longest Jupyter Notebook output I've ever scrolled past. And so we have our piece now, and then we can work on building this cloud build. So in that case, let me defer from doing this step and kind of sort of wrap it up here, unless people want to hear more about the particulars here of experiments and artifacts. In particular with artifacts, you can see the outputs from this artifact. You can see when I mouse over this, if you can, yeah, I don't know if you can read this, but down in the bottom, that URL, here, I'll do this. I'll copy link address and I'll paste it here. And so you can see it's pretty long, and in particular it's source, Mino, bucket, pipeline, key, artifact here. So this is the cloud storage path. Artifact / cover type training, blah, slash. So it's like, it is lengthy. And but if we just click on one, so here's that path, right? But if we click on it, what it'll actually do is it will retrieve it and show it to us. Well, in this case, the value is the string that points to the data. But at least we can see it's correct, right? It's in that hosted KFP folder, and it's dating, datasets, training. Some of the other ones are not as nice, as it were. So these are output buckets. These are the output text. So you can see this is the output of our content. It was, it literally was just, the task was to duplicate the word hello a bunch. But when I click on it, you can see in the path here, it's very detailed. Could have sworn it had a longer path before. Maybe they changed a few things. And what's cool is you can also see the lineage. So this is from a little task that was just to repeat the lines of text, and that outputs a body. Maybe that's why I wasn't choosing the right one. What's the output of this one? That's the validation data. This one's blank. It's weird. And then this is job ID. That's our job ID. So artifacts can be strings. It can be What else? Aside from, you can even have them be like images and things like that. I'm gonna skip over to this one. So file passing was one of the outputs that, one of the tutorial pipelines that come with it. So everybody has this data passing in Python components example. And what's neat about it is you have these numbers, and then it splits the even and odd lines, so you can see them here. You have the 2, 4, 8, 6, 10, and then the odd ones are there. So that's kind of neat in terms of, it works. And you can choose which one you want to see. If you click this one, it'll go to this page that you see here, where you can explore the lineage and you can see other properties about it, and then click this and it'll give you the actual value. Or you can go to, in the artifacts window, you can directly click the link on the right under this URI heading, and you can directly go to the value, right? Or in the case of this one, those are the even lines, odd lines, the numbers, all the numbers, so many numbers. And then the output, what was the output? Yeah, maybe that's like a sum or something. I don't entirely remember what that one was creating, and it makes output text as well. So a couple of things there. One final thing I'll note is that oops, I made this window too big. One thing I'll note is that this lab, even though it's under all these folders, there is support in Kubeflow pipelines, and specifically in this deployment of it in AI platform pipelines for TFX. So TFX is TensorFlow extended, and so if I'm in here and I go up one level and I go to workshops, you'll see there's actually 2 workshops. The one we were in is called KFP-CAIP-SKLearn. If you want to use TFX, or you want to experiment with TFX in AI platform pipelines, I encourage you to go check out this workshop. So you can click into that and you can see it's also a multi-part walkthrough. And it uses TensorFlow 2.1 on TFX running on AI platform pipelines. So Kubeflow pipelines in this case is operating as the runner. It's the software infrastructure, you could think of it, that TFX is executing on. It's the execution environment. And Kubeflow pipelines, that's the execution environment. And earlier when we were saying KFP, this is using the Kubeflow Pipelines SDK on Kubeflow pipelines versus using the TFX SDK on Kubeflow pipelines. So it's the same underlying software infrastructure, just a different language to express what you're trying to do. Julian asks, what do I think about the trend of moving towards SQL with BQML, BigQuery machine learning? It seems to have removed a lot of the frictions that I've outlined here. Absolutely. So this is a really interesting development, right? You say trend. In some ways, it's a one-off. I haven't really seen any examples of machine learning being implemented in other kinds of SQL environments. I'm sure we'll see that coming. So addressing it as a broader trend, I think it's really good for one-off, or not one-off, but lighter weight operations. I don't know that BQML. I'm trying to think, how are you seeing BQML being useful from a kind of data gathering, rerun? Yeah, when you say trend, you mean people like me using GCP. That's fair. And this idea and this directional push, right, of having a lot of the analytics moving to the place where the data is definitely very interesting, and I think it's got a lot of potential. My colleagues and friends, Felipe, as well as like Chad and Jordan Tagani, who are some PMs in BigQuery, they definitely see it as the path forward. And moving the compute to your data certainly makes sense from the standpoint of inverting the model that we used to have in our mind of moving the data to our compute. At the end of the day, we just want them to be together, right? Whether you want to move your data to where your compute is or move your compute to where your data is, that's 6 eggs, half a dozen. It's the same thing. And so in that sense, I can see it working. I I think the limitations here will show itself in the form of whether or not such an environment can reach the level of expressivity that is needed in order to successfully do the kinds of operations and the kind of work you're trying to do in these contexts. So for example, early on in BQML, all it could do was linear logistic regression and classification. Now it supports TensorFlow models, AutoML tables, deep neural networks, all that stuff is getting added to it, and as a result it's becoming much more robust. But it's still in SQL, and that aspect of it will be very interesting to watch to see how BigQuery continues to merge these two environments together, right? Merge the compute environment and meld it directly into the data storage, because for something like BigQuery that is such a magical kind of data storage and data retrieval system with kind of this really powerful SQL layer on top that's extremely expressive for manipulating your data, it totally makes sense to be able to not have to move your data somewhere else and just like do the compute there. And so I could see a world where you're able to more directly hook into BigQuery using your Python, using the libraries you know and love, maybe even doing something as kind of sophisticated or deep dive as providing a custom container. And Julian adds that he warns that doing data cleaning in SQL will make one hate oneself. That's fair. Yeah, data prep is nice for that. Data flow, data proc, like there are ways to move your data cleaning into other environments. And so if there are other options for you for that, definitely go for it. But in terms of moving from the data is in a state that is ready to be used for machine learning in BigQuery to I've used the data now and I've done something with it and our model is deployed, making that bridge happen within BigQuery is really fascinating, because especially in the context of running the model on the data that's coming back into BigQuery, right? That I think is one of BQML's key features that really you don't really see anywhere else, is you can build a model and then deploy it to BigQuery and then have it run on new data coming into BigQuery, and that part of it is really fascinating to me. Let's see. So yeah, I think it definitely has a place, and yeah. So yeah, Julian agrees. Yeah, this is kind of why BQML is so innovative in that regard, and part of it is kind of usability. As the usability improves, it's already quite good, but I really want to see, because we have like UDFs, right? User defined functions. Those are in JavaScript, and it's like, how many languages am I going to have to master in order to use this tool? You have SQL, you have JavaScript, you have hopefully Python, right? Even if you're just using the SDK, but like it would be really cool to be able to run Python within BigQuery and not have to bolt it on, right? Whether that's hitting it with the SDK via notebook, or maybe you run a cloud function, or you use Cloud Run with Python or Node or something to use the BigQuery SDK to link into it. If we could put the code directly with the data, right, just like BQML is doing, I suspect part of the challenge of that, if I had to guess, is that BigQuery is so optimized for SQL at this point, right? It's so developed for SQL that it is very much tuned for the set of operations SQL can do. SQL is nice in that it's a query language. That's the QL of SQL, and that means that the operations that can be done are very well defined. And that means the hardware, the software, all the infrastructure layers can be optimized for those tasks. And so something as arbitrary as Python or JavaScript can really throw a wrench in things, in that you don't know what the user is going to want to do. That being said, having a closer integration with some of these kind of training tools. Like imagine being able to kick off a training job on AI platform training that doesn't involve pointing to cloud storage, but just says, here's a BigQuery query, not even table, a BigQuery query. Though it wouldn't be that different from like just a view, right? If they supported views, you could just put the query in a view and you'd be done. But it's like, why do I have to go through this extra work? If you're supporting that, just support taking a query anyway. And that would be really interesting, because that means the stuff that you're training on will dynamically change as the query gets run each time the training is kicked off, and you won't have to do any of that. And even though making that query might, as you said, make one hate oneself, it would be hopefully a one-time pain that you can just tweak and maintain going forward. Or if you can change the way you collect that data in a way that is more close to the form you want it to be in the first place. That's another way to get around that. So yeah, in general, I hope that was useful. And let's see, I'm trying to remember if Shantanu had said that I needed to make sure I remember talking about anything else. But in general, I think that kind of leads us in a good place. And I know folks have to get going. It's Friday afternoon or Friday evening in some parts of the world. So for now, I'll say goodbye to you all on this AI Huddle, and a reminder that next week we've got a really special AI Huddle. Let me see if I have the screenshot up here. I think I do. So let me, whoops, that's not the one I wanted. Yeah, this one. So this is what we're going to be doing next week. We've got a special AI Huddle that is in collaboration with Kaggle. And we're going to be focused on accelerators, all about GPUs and TPUs with Chris and Abhishek from NVIDIA. And I don't remember where Abhishek is from, but the bottom line is it's going to all be about GPUs and TPUs. And it's just 1 hour. They each got half an hour, so it's going to fly. And we were talking with Chris the other day. He's got a notebook that he trained, I think he said one epoch trains in 22 seconds. He's got some really snappy GPUs tied to that data set. It's going to be the Bengali handwriting data set. That was he's placed very high in that competition. I guess their one is a 3-time grandmaster, the other is a 4-time grandmaster. It's going to be awesome. So I'm really excited to host them on next Thursday at 10 a.m. Eastern, 1 p.m. Pacific, I want to say. For the AI Huddle page has all the details, or you can head on over to Kaggle and get that. So with that, I'll see you all next week. We have, let's see, Tuesday is the Cloud Talks with DevRel 24-hour, host-a-thon. I'll be hosting the final 8 hours of that, so that'll be a bit. And then Wednesday we have the data show. Felipe will be back, and we'll be talking, I think we'll be doing a RIMA time series. And then Thursday we'll have this awesome Kaggle Grandmaster Master class, I guess, right? So yeah, with that, thanks everybody for joining, and enjoy the rest of your day, enjoy your weekend, be safe, be well, and until next time.